Welcome to JC Connect. Yesterday we were discussing about the different details about the different kinds of bricks, and also we have discussed um, the classification of the bricks and the different types of bricks. So now this is a very important question from now onwards. Maybe they will ask the um, mm, what kind of test you are going to conduct on the bricks. So normally we have studied different kind of test which we are going to conduct on the concretes, and the cement also we have studied, um, aggregates also we have studied. So similarly, the compressive strength is one common property or the that you have to conduct for all kind of materials which you are using it for the building materials. So the first one is compressive strength. So the compressive strength, how we are going to conduct this compressive strength. First, what you have to do is that, of course, tensile and flexural strength are, of course, they are very important, but normally we will not conduct on the compressive strength. Why? Because the compressive strength, normally the compressive stresses are more on the walls of any of the buildings. Normally the tensile stresses are very less, so that is why we will not conduct the tensile strength. So the first one is compressive strength. So then how we are going to conduct this compressive strength? So then take 5 bricks uh, at randomly. Suppose if you are um, um, using some um, one lorry of the bricks, in that don't consider it from a series, you consider it from random. And when you select that random bricks, first your job is to determine the dimensions of each of the bricks. So then what you can do is that you immerse all those 5 bricks into the water, and at every interval you measure the temperature. Before immersing, you measure the temperature, say for example 25 degrees centigrade. So then after 24 hours also you measure the temperature. And normally, um, if it is more than um, uh, 30 degrees centigrade or less than 25 degrees centigrade, uh, of course it is not recommended, but the standard code, it will say that the temperature of the water should be in between 25 to 29 degrees centigrade, or up to it is 30 degrees centigrade. So make sure that the temperature should be in between 25 to 29 degrees centigrade. That is why before immersing the brick, your to um, uh, job is to make sure that the temperature of the uh, initial temperature as well as the final temperature of the bricks. So then surplus moisture is allowed to drain after 24 hours. Then um, if whatever moisture is allowed to drain, and the frog also, uh, then fill the mortar with 1 is to 3 composition. Then it is kept under a jute bag for under 24 hours, after which it is immersed in a clean water for 3 days. Again you have to immerse that in for about 3 days. Then at the time of testing, these bricks are removed from the water, wiped dry, and placed with a flat surface between plywood sheets, each of 3 mm thickness. So normally you have to select the plywood sheets which are having 3 mm thickness. And here it's very important thing is that when you take it from the water, normally make sure that um, up to 10 to 15% of the water content should be there, the not more than that. Okay. Even you can take the weight of that. After taking, make sure that total increase in the weight should not be more than 15% of the initial weight. That is why I told you to take the initial weight of the bricks. So then this specimen is kept under, of course, UTM, and load is applied. So of course you can do it by UTM itself. Of course the whatever the bricks are there, it will take less load compared to your normal cement and concrete types of or RCC type of bricks. Then the UTM, that is universal testing machine, you have to use it for the testing of the bricks. Then you apply the load. So then compressive strength should be noted down. See the when it is going to break the bricks, at that point note down it. So then water absorption. So here also you have to take 5 bricks. Then they are allowed to dry in an oven at 110 degrees centigrade or 115 degrees centigrade till they attain a constant weight, usually takes place in 48 hours. So water absorption, normally you select randomly here also, as it is discussed in the compressive strength. Then before um, um, immersing into the water, make sure that it should be completely dry. So then how to make it dry? So if you want to make it dry, what you can do is that you keep it in oven, that is microwave oven. So you can maintain the temperature of 110 degrees centigrade to 115 degrees centigrade for about 48 hours. Then they are cooled. Then take it out, cool it properly at room temperature, which generally takes 4 to 6 hours without a fan, and that weight is measured. So don't simply take it randomly by the weight. It has to be taken into the oven, then dry it, cool it, then the weight has to be taken and it is measured as W1. Then uh, keep the um, that all 5 bricks in a clear water at 29 degrees centigrade for about 24 hours. Then wiped dry with a damp cloth and weight W should be measured. So this is very important. Normally clean water he is saying. Normally, actually, strictly speaking, we have to use the distilled water, and that has to be immersed into the all bricks. Why distilled water? The reason behind distilled water is, normally distilled water does not contain any of the ions. If any ions are there in the distilled water, um, that has to be absorbed by the bricks. Then normally the property of the brick is going to change and it is going to affect the water absorption. So that is why he said that it is a clean water. So normally we will use it distilled water. So even what we'll do is that before proceeding into the, whether it is a clean water or whether it is mud water or something like that, if mud water is there, you are not supposed to do it, because the mud water um, um, always consist of this organic matter. This organic matter is very dangerous. This organic matter normally, when it is enter into the brick, normally the disintegration is going to happen. To stop this, normally we will not use any mud water for the immersion. So then how we are going to judge whether it is normally when you are saying it, it's looking like a clean water, but you have to test it with the help of the conductivity meter. See that the conductivity should not increase 100 microsiemens per centimeter. See, normally the conductivity of the distilled water will be in the range of 50 microsiemens per centimeter. So then it should not increase, that is, it should not be greater than 100 microsiemens per centimeter. If it is more than 100 microsiemens per centimeter, normally we will not use that water for the immersion because the conductivity is high. what causes this increase in the conductivity? See, normally to this increase in the conductivity is due to the presence of dissolved solids that are present in the water. So that is why, as far as possible, the dissolved solid should be removed, and the conductivity should be reduced. Then that kind of water should be selected and it is used for the water's absorption test. So then, uh, normally the temperature of the water should be maintained around 28 to 30 degrees centigrade, and you have to immerse that um, bricks for about 24 hours, and wiped dry. Means what you can do is, once you take it from uh, the uh, the whatever the pond is there, then take it out, then dry it with a cloth, then take the weight as a W. Then difference between the W2 minus W1 will give you the uh, will give you the um, how much water is absorbed. Even that you can do it in the percentage also. So then average percentage of water absorbed as a percentage of dry weight is reported. So this is also very important property, because normally with this water absorption property, the durability aspects of the bricks can be calculated, because normally when you keep the bricks in the rainwater, whether it is going to absorb or whether it is going to damage, or how much damage is going to happen, that can be analyzed with the help of water absorption property. So then we will move on to the efflorescence. So efflorescence means, maybe you have seen that um, this efflorescence means the occupation, um, or um, the dust particles which are going to accumulate on the surface of the bricks. So if you keep the bricks for a long time, so whatever the dust particles or white type of particles which are going to accumulate on the surface of the bricks. So on the surface of the bricks, it is going to accumulate whatever the dust particles. And if you see the bricks, you can see that you cannot see, suppose if it is a red type of bricks, you cannot see that red color. It is that red color is replaced by some of the white type of dust type of the particles on the surface of the bricks. So this normally we can call it as efflorescence. Then how we are going to conduct how much this efflorescence particles or the dust particles are accumulated on the surface of the uh, this bricks. So then what we'll do is that we will take 5 samples. Of course, take it randomly, how we have taken in the compressive strength as well as the water absorption test. Then the bricks are placed vertically in a dish that is 30 centimeter by 20 centimeter approximately, in a size with 2.5 centimeter immersed in a distilled water. I already said, even when you are uh, uh, doing this test also, make sure that it should be in distilled water. For the previous case, I already said that the conductivity of the water should be less than 100 microsiemens per centimeter. But when you are doing the test for this efflorescence, normally the conductivity water should be less than 15 microsiemens per centimeter. Normally what will happen is that if means it should be completely pure distilled water. If you say, if you take the completely pure distilled water, even if you check the conductivity of that, it is less than 15 microsiemens per centimeter. With the help of the conductivity also, what we'll do is that we will check the quality of the distilled water, whether it is distilled water or whether it is the ionized water. But the distilled water is not good for drinking water. Of course, for us, distilled water is not good because distilled water does not contain any of the ions, but our body requires some of the micronutrients like magnesium, manganese, some of the nitrogen based compounds also we required for our body. Manganese, potassium, K also is required, sodium is also required. So but for this test we use distilled water. Then water is allowed to be absorbed by the brick and evaporated through it. Then what you can do is that immerse in distilled water, let it absorb, even if it is a 50 microsiemens per centimeter, what I said it, even it contains very small minute amount of some of the micronutrients, even that is going to absorbed by the brick and evaporate through it. So you evaporate with the help of some of the heating equipments. Then you say the result as a nil, means you declare the result as a nil if there is no perceptible deposit of salt. If any salt deposit is there on the brick, then you report it as no efflorescence, means there is no dust particles on the bricks. Then you report it as slight if it is not more than 10% of the area of the brick is covered with a salt. This what we have to do is that you take the brick, find out its dimension first, and find out its area also. So then what you can do is, once you found out the total area, then see that how much percentage of area is occupied with the salt. How you will say it is occupied with the salt? Normally if the salt is accumulated, then you can see the white type of precipitate on the surface of the brick. Then if it is 10% of the total area, then you record it as a, or report it as a slight. So then you report it as a moderate if heavy deposit covering up to 50% of the area of the brick is required. So it is heavy deposit covering up to 50% of the area of the brick, means if you have 10 meter square area of the brick is there, suppose if the salt is occupying 5 meter square area, so then you record it as um, moderate efflorescence of the bricks. So if it is a heavy, normally the heavy deposits of salt, if it is more than 50% of the area of the brick, so then you note it as it is a heavy deposition of the salt particles on the surface of the bricks. So normally the efflorescence is a very important characteristics. Normally uh, uh, when you are using the bricks for as a surface material or enhancing the uh, beauty of any of the buildings, normally the special case of the bricks, normally we will use it, and the efflorescence should be zero for the special case of the bricks, that has to be maintained. Suppose if you are using it for the special case of the bricks. Normally dimensional tolerance. So bricks are selected at random. Of course, I already said that it should be checked with a random the measurement of length, width and height. Suppose if you are taking a truck of the bricks, take it randomly and you measure the dimension of that each of the bricks when you are using it for efflorescence. Variation in the dimensions are allowed only within the narrow limits, like plus or minus 3% for class 1 and plus or minus 8% for other class. Normally when you are using it for this fluorescence testing, uh, dimensions are allowed. For example, if you are considering 5 bricks, make sure that you select some 5 bricks. Then there is and when you are selecting, the deviations of the size is allowed up to 3 to 8% plus or minus deviation the size is allowed. But it should not be, of course you have to select it randomly, but the size of each bricks should be allowed up to 3 to 8% for the different class of the bricks. That range is there. That range you have to follow it based on the size different class of the bricks. That is classification you already discussed. You see what kind of class of bricks we have to select and how much variation is required. So then hardness property, it is a scratch made on the surface of the brick with the finger nail. So in a good brick, no impression will be left on the surface. This is very important. Then how we are going to test this hardness of the bricks? Normally you take that brick, so scratch it with the help of your fingernail. If it is a good brick, so no impression will to be left on the surface. So if the any impression is falling on the surface, say that it is uh, having more hard and it's more stiff type of the brick. Normally we sometimes this more hardness of this bricks is not good for the construction. Normally if it is more hard, there are many chances that the disintegration will be faster, and it should not be too smooth also. So for that, what you have to do is that make sure that it should be, or no impression will be left on the surface of the brick. That we can call it as the hardness property of the test. So then soundness, so two bricks are taken, one in each hand, one in each hand. They are struck with each other slightly. A clear ringing sound should be produced, and the brick should not be get break. So then normally take two bricks, then one on the left hand side and one more on the uh, um, right hand side. Then you bombard each other two bricks. So then it should not break first one. Then a clear ringing sound has to come. Means clear ringing sound means what? When you starting point, when you start it from then slowly uh, the sound has to decrease, and suddenly the sound should not has to stop. That is what the meaning of the ringing sound. So sudden, it should not stop the normally this sound will be around it will be declared as up to 5 to 6 second, but when it is traveling from 1 second to 6 second, the slowly the sound has to be reduced. So this is what the soundness test of the brick. So if they ask what kind of test you are going to conduct it on the test, so you say it as you explain. First one, that is a compressive strength, then second one is a water absorption test, and the third one is the efflorescence, and the fourth one is the hardness, and the fifth one is the soundness test. We are going to conduct it on the bricks. So these are the different properties of the bricks which you are going to conduct effectively. Of course it requires some of the instruments. For example, compressive strength, you requires a universal testing machine, and for water absorption test you require distilled water with one chamber where you want to immerse the water or the brick. Even uh, this whatever the soundness test we are talking about, the soundness of the concrete also we are going to conduct. Whatever we are talking about the ringing type of the sound when it is going to break, when it is going to break, or when you take the two concrete blocks, then try to bombard each other, the ringing sound has to come um, with help of that bricks. Of course this whatever the ringing sound or um, uh, this what you are talking about, it is the variation is from 1 to 10 seconds for different times. Some bricks it will be restricted to 5 seconds, and some bricks it will be up to 7 seconds. Some bricks it will be going to finish within 4 seconds. Of course if you are talking about the first class type of the bricks, it is restricted to 5 to 6 seconds. So normally at the first second it should be more, and the when it is going to decrease, and it has to end by um, up to 5 seconds. Then normally the decibel if you are talking about, it is normally the sound is measured in decibel. It will be 30 dB, and 32 it has to decrease up to 15, or it is going to decrease within 5 seconds, and it has to zero within 5 to 6 seconds. So 30 it will starting, 30 dB is the starting sound, and it is going to decrease 0 at 5 seconds. So in the next class maybe we will move on to the third module. Today we'll try to finish all these types of tests, and it is all these are the my 5 important properties of or tests on the bricks. Thank you.